Good morning friends, welcome back to my channel Coding Environment. This is the video number 2 of the linked list series. In this video, I am going to cover the following topics, which are how to create a node of a linked list, how to add a node at the starting of the linked list, how to add a node at the end of the linked list, how we can add a node after n nodes or at a given position in a linked list, and how to print the nodes of the linked list. So these are the topics I'm going to cover in today's video, which are the very basic topics on the linked list. So let's see these topics one by one. The first topic is how to create a node of a linked list. So what is a node in a linked list? In a linked list, the node can be divided into two parts. One will hold the address of the next node and the other will keep the data of the node. Now the data can be one value or can have multiple value in it. For simplicity, I have kept only one data, which is a type of int in this data part, and this next variable will hold the address of the next node. So we can create a class called node which will have a data variable and having a next variable which is going to hold the address of the next node. The next topic of this video is how to add a node at the beginning or starting of a linked list. So when we are going to add a node at the starting of a linked list, there can be a two situation. When we are trying to add the node at the starting of the linked list can be empty. In this case, initially the head will point to the null. And when we are going to create a node or when we are going to add the node, which will be the first node of the linked list, we can point this head to the newly created node. The second situation is when you're trying to add a node, there is already existing one linked list and you're trying to add the node at the starting of the linked list. In this case, your head was initially pointing to this node. But when you're trying to add the node at the starting of the linked list, what we have to do is the new node which we have created, its next will point to the already existing linked list head node, and the head will now point to the newly created node. I will show this in the code. So let's see how we can write this method which will add a node at the starting of the linked list. Now to save the time, I have already created a structure for all these methods. We will fill all these methods one by one. Now the first method is add a node at the beginning of the linked list. So we will fill this method one by one. Now the first situation is like when you're trying to add the node or the new node, the head is pointing to the null. It means the linked list is currently empty. So what we can check is like if head is equal to null, which is the case when the linked list is empty, we can create a node which will be a temp node. So I have already written a constructor which will create a node and set the data of that node also. So I'm going to set this data like whatever the data we are passing here, and the next node is pointing and the next node is pointing to the null. And the head in this case will now point to the newly created node, and we will return this head. So this is the case. So this is the case when your linked list is empty and you're trying to add a node at the starting of the linked list. So in this case, this head, if head is equal to null, it means your linked list is empty. If this is not the case, it means you have already some node in that linked list. So what we have to do is like we have to create a node which will be like creation of node, which is temp new node, and you can create new node data, and then this will point to null. Now what, after getting this, we have to point this next to the already existing linked list head node. So this was the head node previously, right? So this next will point to the head node. So here your temp new node dot next will point to head node, and now the head node will point to the newly created node, right? And then we have to return this head node. So this is the code to create or to add a node at the starting of the linked list. So this is all about adding the node at the beginning of the linked list. Now let's see the other topic of this video. The other topic was add a node at the end of the linked list. So this is also coming into two situations, like when you're trying to add the node at the end of the linked list was previously empty. It means that a head was pointing to the null. In this scenario also, we are going to create a new node and we will point the head node to the newly created node. And the second scenario is like when you're trying to add a new node, there is already existing one node. Then what we have to do is like we have to traverse this already existing node and reach to the end, and then we have to attach this newly created node to this end node of the already existing linked list. So let's see how we can do this through Java code. So this is the method I've already written, the signature I've already written. So in this we are going to pass the head node and the data which we are trying to add at the end of the linked list. So to do this, the first situation again will be the same, which is if head is equal to null, we are going to do the same thing which we have done when we are trying to add the node at the beginning of the linked list. And if this is not the case, it means your linked list is not empty. So we have to first traverse the linked list and then add the node at the end of the linked list. To do this, we have to first traverse it, right? So we can create a temp node for traversing, and this head will assign to this, and then write a while loop and see how we can traverse or reach to the end of the linked list. So the property is like the end node of the linked list will point to the next node, right? So what we can do is we can traverse till temp dot next is not equal to null. To do is like we have to. So this is the way we will traverse a linked list. What we will do, we will create a temp node and then keep on traversing. So see this, like what we can do is temp equal to temp dot next. So this is a very important line in traversing a linked list. This, what it indicates is like first this temp will point to the head, and then we are assigning the next node into this temp, right? So each time, like what will happen? So previously the temp is pointing here, right? And with this line, with this temp is equal to temp dot next, what will happen? That temp will now point to this, right? Because next is pointing this one. So your temp will move here, and again it will move here, and again it will move here. In the code, this next will point to the null because this is the last node of this linked list, right? So this is the case, like when it will reach to the end of the linked list, this condition will become false, like the temp dot next will point to the null. When temp will reach here, its next will point to the null. And once you reach here, what you have to do is like you have to the already created node, right? So first we have to do is like we have to create a node again, which is nothing but node temp new node equal to new node and data, and then we can say null, and we are here. So temp is basically pointing to this place. Now if we set like temp dot next, which was previously null, to temp new node, It means this 40, right? This next is now pointing to this newly created node, and this is already set to null, so we don't have to do anything. And from here we can return this head node, because head we have not done anything, right? So head is still pointing to this node, so we can return head node from here. So this is all about adding a node at the end of a linked list. So moving to the next topic of this video, like how we can add a node after a given position in a linked list. So when I'm trying to say, when I'm saying this, so suppose you have been given a linked list like this 10, 20, 40, and 50, and somebody is saying you to add a node after two nodes of a linked list. So they will give the data like 30, and they will give the position also. So they will give the position like 2. It means that after two nodes, you have to add this node which value or data will be equal to 30. So how you are going to do this in Java? So to do this, right, again we have to like this method already I have created the structure. So in this, if you see, it takes the head node, the data which are going to add, and the position after the position, which indicates after how many nodes you are going to add this new node. Now to do this also, again there will be one situation can happen, that when you're trying to add this node, the linked list itself is empty. In this case, like if head is equal to null and the position is greater than 0. So you are trying to say that I am adding a node after second position or after first position, but your head is pointing to null. It means that linked list is empty. In this case, we can return or anything we can do. So this is a situational based condition. How you're going to handle this situation. So you can return some error, you can print something, anything up to you. So I'm not going to indicate what we can do. So I'm just printing here that my linked list is empty. My linked list is empty. So you can do anything. You can throw an exception or something. So anything can be done in this case, but for simplicity, I'm just printing that my linked list is empty, and I'm not going to add anything. So I'll return head from here, because this is not a correct situation. If your linked list is not empty and you're trying to add the node which is under the boundary or less than the length of the linked list, how you can do this? I'm going to write the code for it. So for this, what we can do, we have to again traverse the linked list. So for traversing, what we have seen is like we can create a node which is a temp node, and I will assign the head to it. I will run this while loop on this temp node. Temp.next is not equal to null. And what I will do is I will because I checked one node, right? So I am going to decrement my position, and if my position is equal to 0, I am going to add a new node. So if my position equal to 0, I'm going to create a new node, which is like new node data and null, and then I will assign this new node. I will assign this new node into the temp.next node, because I have already reached 0, right? So I will show like how this code is working. So if just let me write this code. I have to temp.next will now point to the new node which we have created. So before that, the temp.next, we have to save, or basically what we have to do is in this new node. So my new node dot next should point to temp.next, and now my temp.next temp.next should point to new node. So this is and that's all. Like after you do this, you have to just return your head. From here, yes, if you reach here, you can do here, and from here you can break it also. So once you completed this part, you can break this code. Now, yeah. So this is all about adding a node at a given position. So let me show how this code is working. So what we have done is we have like how we traverse a node, right? So we have created a temp node, and temp.next is not equal to null. And if position, so just assume that you have given a position 2, right? So what will happen? This temp.next is not equal to null. First time you will decrement this position, and this will say is this position is not equal to 0. So because at first time the position will be equal to 1, right? Now, okay, it's better I can run this code into the debug mode itself, and let's see how we can do this. So just run this code into the debug mode. Now see, in this, I already have a linked list which value is nothing but 10, 20, 30, 40, 50. It means I have a linked list whose head is pointing to 10 and the tail is pointing to 50. And I am trying to add a node or a data which value is 35 and the position is 3, right? So what I'm trying to say, I'm trying to add this node after this 30, after this 30 data. So basically after the node third, 10, 20, 30. After this, I'm trying to add it, right? So let's see how this code is working. We'll do a stepwise. So now the position is equal to 2. It is still not equal to 0, right? So this will come out. And now in the next point, this temp, if you see this temp, now the temp is pointing to 10. Temp will be pointing to 10, 20, okay. No, okay. So there is something wrong here. What I have not done is in this while loop, okay. So let me break this, and what is wrong here is like we have to move to the next node if it is this position is not equal to 0, right? So what we have to do is like temp equal to temp.next. Okay. So now run this code again. Now if you see this, we already again have this linked list already created. So it has 10, 20, 30, 40, 50, and now just run this code one by one. So see this, in this position 3, first time it was position 3, now we decremented it, and now we will move to the next node. So this position is not equal to 0. Now this temp will point to the next node. So if you see this temp is nothing else but pointing to the next node, right? Again, because we will move the position 1, now again it is not reached till 30. So if you see this, it is again, now this temp is 30. And if you see this position will become 0 because we decremented it. So we have decremented this 3 times and we have reached at the position where we wanted to add this node, or where basically where we wanted to add this node, or basically where we wanted to add this node, right? So see, if you see it, so if you see this position 30, now just because position is equal to 0, and actually we have passed it as a like after third node we wanted to add this data 35, right? So it is going to create a new node. Once the new node is getting created, now the new node dot next will point to the 40. So if you see this new node dot next is now pointing to 40, but your 30 dot next was previously pointing to 40, which should now point to new node, which is 35. So to do this, we have to say new node dot next equal to temp dot next. So this temp dot next is equal to new node. So this is the line which you have to execute. And if you see this, now your temp node is also pointing to 35. Sorry, this temp node, temp is where we here temp is now pointing to the 35. So after that there is nothing. It is just going to break and then come out of this loop. So now let's write the code, which is the last part of this video, like how we can print the data of a linked list. So to do this, there is again one situation can come where your head is equal to null. In this, there is basically no data, and we have to say that system.out.println and linked list is empty. And from here only we can return it out also. So from here only we can return it. But if there is some data, what we can do? We can again traverse it. So we can say till head is not equal to null. We can print the system.out.println, and then how we can get the data? So node dot data. Okay, basically not node, it is a head dot data. And once you print it, you can come out. So we can just make some gap here because I'm going to print this many times. And now it's time to test all our code. So see, if you see this driver code, which is the main code, what I have done is I have created or I have added a node at the beginning of the linked list 3 times. So when you run this first time, right, when you try to add this first time, it is going to add 30. After that, it is going to add 20, and after that, it is going to add 30 or add 10. So the sequence is like you are going to add 30, right? Then 20, which will be before 30. So the linked list will be like 20, 30. Again, if we're going to add 10 at the beginning, the linked list is 10, 20, 30. So after that, if you print, it should print as a like 10, 20, 30. And these two I'm trying to add at the end. So 40, if I'm trying to add at the end, it will basically add after 30. And again, if you add 50 at the end, this 40 will be, this 50 will be added after 40. So after this statement, this print all should print as a like 10, 20, 30, 40, 50. And this node, this is the method which is trying to add the node after the third, right? So this will be like after 30, this 35 should get inserted. Now let's run this code and see what is the output we are getting. So just let me remove this breakpoint. Okay, we have made some mistake. Let me see where that mistake is. Yeah, here. So we have again not traverses. So basically what we have to do is head equal to head dot next, right? So now it should be fine. Let's see. So you can see it here. The first time, like when you're trying to add the node at the beginning, we have first created this 30 node and then added 20 node before 30 and then added 10 before 20, right? So this is the time when we are trying to print this. The linked list is basically 10, 20, 30. And after that, you have added 40 and 50 at the end. So the linked list is now 10, 20, 30, 40, 50. And we have like inserted a node which is 35 after position 3. So this is the position 1, position 2, position 3. After that, we have inserted a node 35, and this is like 40, 50 as the already existing nodes. So this is the very basic of your linked list where you're trying to add a node at the starting or at the end or in between somewhere in the already existing linked list and how you can traverse a linked list and print all the value of a linked list. So this is all about this video. Hope you liked this video. If you liked it, please subscribe to my channel and stay connected. See you soon in the next video.